Hello and welcome to the Muscle Engineer podcast. I am your host Sotak Andrei and this is episode 6 of the podcast in which I am about to be joined by Mr. Brad Dieter from the popular blog Science Driven Nutrition to talk about fructose. And many of you will probably be familiar with Brad, but if you are not, Brad has a PhD in Exercise Physiology and he has written a number of impressive articles on the aforementioned blog, one of which was on fructose itself. And when a couple of months ago had a discussion with one of my university professors about this very topic, a biochemistry professor actually, and during our conversation we actually addressed this a bit. But this particular professor brought up some points that I knew were not really evidence-based, and I just found it very interesting that even a biochemistry professor can be misled by this whole topic of fructose metabolism and its contribution to fatty liver disease specifically. So that's why I wanted to have Brad on to tackle this topic in an evidence-based manner and lay out the current state of the science. During our conversation, we also go into fructose's potential benefits on exercise performance, the role of fruit in your diet, whether you should consume it or not, and a bunch of related topics. So I hope you will enjoy this and you will find it useful. So without further ado, here is my conversation with Mr. Brad Dieter. Brad Dieter, welcome to the show.
Thank you for having me. It's good to be here, and I know we've been trying to schedule this for a while, so I'm excited to be on, and this will be a fun topic.
Yeah, it's great to have you, and I think you're happy that your name is starting to become pronounced the way it's supposed to be, and you're not called Dieter anymore.
Yes, that was the main reason I decided to get my name out in the public, so I could have it pronounced correctly, but no, I'm just kidding.
Just to kick things off, I know you've had a lot of experience with research, specifically with a variety of species of animals, and I I wanted to hear what would be the most interesting or the scariest animal research story you can tell us about.
Oh man, I've got quite a few. Probably I'll share two of them. One of the first big animal research projects I worked on in grad school was studying grizzly bears, where basically we were trying to look at how insulin resistance occurs in grizzly bears and a lot of the hormonal changes that happen as they seasonally start to overeat and become obese, and then how while they're insulin resistant, cardiac function doesn't change that much. And a really interesting project. But one of the first days I was there working, probably the second or third day, I was in charge of giving glucose boluses through a jugular vein catheter because we were doing insulin tests, right? So we've got this 800-pound grizzly bear who's sedated, and my face is about 6 inches from the grizzly bear, and I'm giving them boluses of glucose as their glucose is dropping, and we're doing insulin sensitivity tests. And one thing I didn't realize about anesthesia is you can still have a lot of autonomic activity. So you can yawn is the big thing. So my face is about 6 inches from this grizzly bear, and I'm working, and all of a sudden the bear opens his mouth and lets out this big noise because he's yawning, and I jumped probably 15 feet in the air and ran to the back of the room, and the PI who was in charge of the study who just looked at me and started cracking up because she was laughing so hard that I just lost my mind. So that was probably a good one. And then another one was during my dissertation research, I was running animals on a treadmill, and the vivarium where all the animals were being kept was being remodeled, and so they put me in this tiny little shed that they had built inside this big warehouse in the middle of the basement. And I was at the very end of the study, so the animals were running about an hour at a time, and we could only do 4 at a time. So it was Thanksgiving Day, and I had to get there at about 4:30 in the morning so I could start and get done by I think it was about 6 or 7 at night. But it was the second group of mice for the day. So it's about 5:30 in the morning on Thanksgiving, and I'm the only person in this whole building. And one of the mice just stops running, and he goes to the back of the treadmill, and I try to poke him to get him to run, and he just turns over, falls back, and gets his head stuck in the back of the treadmill and just snaps his neck and dies. So
Oh my God.
I'm the only person in this building, and I'm a grad student, so I have no idea what to do. And I'm like losing my mind because this is the last week of the study, so the other 4 mice, I can't just like stop them, and it was just a disaster. So I had to like call somebody and get them in there, and it was just like it was a tragic experience.
Wow, that bear story, holy cow! I like the only scary experiences I had were with dogs, and they are scary enough. But I can't even imagine what must have been like being scared by a grizzly bear.
Yeah, it was pretty intense, but then being able to laugh it off helped a little bit, so that was good.
Okay, I'm glad you were safe and you were able to have this conversation right now. So let's get to the topic at hand. Let's get into discussion about fructose. So just to kick things off and get everyone on a level field, could you please explain a bit what exactly is fructose and how it's metabolized in the body, starting from the mouth when you ingest a piece of fruit or something?
Yeah, so fructose it's considered a sugar molecule because it's basically a cyclic structure of carbon molecules. It's very similar to glucose in structure, but it's a little bit different. So it has 5 carbons instead of 6. And it's a sugar that comes naturally in the form of fruit, right? So it's one of the big sugars that makes up fruit and what makes fruit sweet. More modernly, it's been used as a sweetener for a lot of food, right? We think about high fructose corn syrup because it makes things taste a little bit sweeter than glucose does. So your brain registers it as a little bit sweeter than glucose. And so when you digest it, it follows primarily the main track that glucose does until it gets to your gut, and then once it's in your gut, it follows a little bit different metabolic fate than glucose does. So it's taken up by different transporters in the gut compared to glucose, and your body has a little bit less capacity to uptake fructose than it does glucose, just because when we think about evolution, what was primarily available and how your body evolved to process things, glucose was a more readily available food source than fructose was. So it gets absorbed a little bit slower through different transporters. And then what happens is your body, you can break down glucose in almost every tissue in your body. You can really only break down fructose primarily in your liver. So almost all fructose ends up being metabolized in the liver. So that's the first big difference is glucose can go to almost all other tissues, and fructose has to be metabolized in the liver. So one of the really big things that has come up, and we'll talk I'll kind of go into a little bit more detail, but for a lot of the lay audience, or I want to say, people who haven't gone really far down the research rabbit hole, is a lot of people have this idea that because fructose ends up in your liver, it has to be metabolized there, it gets turned into fat and gets deposited as fat in your liver. Now, that's really not the way fructose is actually metabolized. So for, over the last 20 or 30 years, there's been a lot of really interesting research that's actually, they've basically taken fructose and they've labeled it with radioactive labels, and they've had people consume it, and then they've watched, where exactly does fructose go in the body and what is its fate and what happens to it. So here's what mostly happens when you consume fructose. And this data holds true for anywhere between 50 and 150 grams of fructose ingestion. So whenever you consume it and it goes into your liver, about 30 to 50% of that fructose is actually converted into glucose and then either stored as liver glycogen or gets shipped out to the rest of the body and metabolized there or metabolized directly in the liver, right? So if you take, let's just say 50 grams of glucose, between 15 to 25 grams is converted to glucose and then either stored or oxidized immediately for energy. And then about 30% of it actually gets converted to lactate. And then that lactate usually goes out to extrahepatic tissues, mostly muscles, sometimes fat cells, and then gets used for fuel there too. And then about less than 1% of it actually gets turned into lipids, right? So the conversion of fructose to lipids is actually a very long metabolic process and doesn't happen at quite the rate most people think it does. So it's actually less than about 1% of fructose actually gets turned into fat. And this has been shown over, not one study, but, multiple studies in which they've actually looked at when you track fructose from when it enters your mouth to where it ends up as a fat, it's about less than 1%.
Mm-hmm. Yeah, that was an excellent breakdown. And you said that if you aren't really familiar with the research, then you kind of get this misconception that fructose is just going to be used for fat storage. And that's not surprising, because I heard this from university professors, including my biochemistry professor. Just recently, I had a conversation with her about this. And there's that, what is his name? There's a professor in the US who is big on fructose.
Robert Lustig.
Yeah, Lustig. He's the one. Yeah, I've heard him on a podcast. I think it was either NPR or Freakonomics. They had an episode.
And I think, part of that misconception comes from the fact that if you do, a lot of these answers depend on your level of analysis. So if you look at just biochemical data, so you just look at basically reactions and enzymes and what happens it is very well established that when you consume fructose, you usually get an upregulation of lipogenic enzymes. That usually comes with because fructose is either co-ingested with other things, or it turns on some molecular machinery that actually makes a lipogenic environment, which is true. But then when you look at the actual output, you don't have that much fat being made. So while you are turning on some of the lipogenic metabolic processes, the actual end result is not large amounts of fat deposition. So that's one of the really interesting pieces. It's a good example of which questions you're asking determines how you view the situation.
Mm-hmm. Yeah, I think there are two big directions we could go with this. We can go in the whole health aspects and the performance aspects. I think it would be easier to just tackle the performance aspects first, because that's kind of easier and relatively non-controversial. So you've mentioned there lactate and glycogen, and both of those can be used as a fuel source. Could you outline a bit how that would happen, and what is the relevance of this for muscular performance, for example?
Let's kind of start with the basics of exercise physiology, and then we can transition into some studies that have been done. So when we think about what happens during exercise at any even moderate level of intensity, is your body starts to break down muscle glycogen to use glucose to provide energy through glycolysis. And then it starts pulling in carbohydrates from circulation, glucose from circulation to fuel your performance. And then your body also starts to use lactate, right? Lactate becomes a fuel source. So one of the big things we have learned over the last 30 years, 40 years of exercise physiology literature is whenever you consume glucose, right before or during extended training periods, is the glucose actually that you're consuming actually ends up providing more blood glucose and energy for your muscles, so you can train harder and you can train longer. Now, the other thing that we know about exercise physiology that we've learned is during periods of higher intensity exercise, the main way that your body provides extra blood glucose is you start spitting out glucose from your liver, right? So if you go in and you start training really, really hard, your body actually pumps out glucose from your liver so you can have more blood glucose than to use during training. So there's a few pieces of that then actually starts to make us think, is there a role for glucose in exercise as a, intra-workout nutrient? It's very clear that there is. But could there be a role for fructose, right? If we know fructose has to be metabolized by the liver before it gets to the muscles, can fructose actually do anything for exercise performance? So probably one of the best studies on this was actually done by a young scientist, Jorn Tromelin, and he actually wrote about this on my blog, and it was a really interesting piece of research that had findings that I wasn't exactly expecting. But basically what they did is they took groups of people and they fed them either just glucose and fructose, and then glucose and sucrose, which is sucrose's table sugar, which has 50% glucose and 50% fructose. And basically what they looked at was kind of a few main outcomes. One is post-workout muscle glycogen. So does just glucose or glucose and fructose essentially improve recovery in terms of muscle glycogen? And then how do glucose kinetics differ? And how do blood lactate kinetics differ between these different conditions? And basically what they were able to show is if you take people and you feed them just glucose or glucose and fructose or glucose and sucrose, which has fructose in it, is the best way to recover muscle glycogen post-exercise is actually a combination of glucose and sucrose. So you have, a little bit of fructose in there. And I think there's probably a few main reasons why that happened. One is the fact that when you are training and you need to replenish your liver glycogen and you provide fructose, part of that fructose ends up preferentially stored in your liver, so then the rest of the glucose can actually go straight to your muscle glycogen. So if you give somebody just glucose, it's got to be split between liver and muscle glycogen. And that was one of the things that they tried to show, was that a little bit of fructose on top of your glucose load actually helps you recover muscle glycogen faster. And the ratio that it was consumed at in that study is about 2-to-1, right? So a 2-to-1 mixture of glucose to fructose. So if you're trying to maximize recovery, it looks like having a little bit of fructose having a little bit of fructose in terms of replenishing muscle glycogen is a much better way to do that than just having glucose alone.
I usually just have my intra-workout shake and I have dextrose, and recently I just switched to sugar because it's cheaper and I have it at the gym. We have free coffee, so it's just there, and some people give me weird looks when I just pop it in my shaker bottle, but it's effective. So alright, another concern that is especially relevant for people who are interested in bodybuilding is this whole issue of muscle glycogen, just because, like you said, fructose is mainly used to refill liver glycogen. So one question that usually comes up when the topic of refeed is discussed is whether you should consume fruit or not during this 24-hour or however long that period is. Because by that logic, if you want to refill muscle glycogen specifically and fructose is just going to refill liver glycogen, then should you bother eating fruit at all, or should you just focus on keeping it as low as possible?
Well, I think, this study that Jorn did is a great way to segment into that population, right? So what do we know about refeeds? Refeeds are usually very large boluses of carbohydrates. Now, if you're just consuming glucose, you have to split that glucose load between liver and muscle. If you're consuming a little bit of fructose with it, you're basically saying, okay, the fructose is going to help go to the liver glycogen replenishment, and the glucose is going to go to the muscle glycogen replenishment. So I don't think it's a very sound argument to say, oh, if I'm consuming fructose, I'm not putting sugar into my muscles, right? You're actually helping divert what you are consuming in glucose to muscle tissue. Now, I don't think there's actually been studies done where they have done this, where they've taken large refeeds and given, 20% fructose and 80% glucose and seen where the kinetics go. So I don't think there's any hard evidence to back that up. But the data from Jorn's study, if you kind of extrapolate that out to what would happen in a refeed scenario, I think that's probably what you would see. So it actually, amongst the 6 cups of rice you're eating that day to hit your 600 grams of carbohydrates, a couple bananas or a couple high fructose fruits are probably going to help you kind of differentiate where those carbohydrate molecules are actually ending up.
Mm-hmm. Yeah, I think especially with something like a banana, for example, which is kind of low in fiber, because I usually just eat apples, but those are a bit higher in fiber, so that can be an issue. But if you have a banana or something like that, which is pretty low in fiber and high in sugar, that should do the trick pretty nicely. Okay, I think that covers the performance aspect pretty nicely. I think as a nice summary, it would be prudent to have some sort of a fructose source, whether that's from a fruit or honey or even sugar, to use that to replenish glycogen stores in all the tissue. If we then head into the health aspects, you've mentioned there fructose and fatty liver. So is that concern really relevant? Should we worry about fructose leading to non-alcoholic fatty liver disease? Or is that something that kind of has a bit more context behind it that most people would tend to believe?
Yeah, so I think we'll probably step through this in several levels of analysis, and that'll kind of help orient people. So the idea of fructose being causal in non-alcoholic fatty liver disease, the hypothesis arose from, the idea that fructose is metabolized in the liver and it can get turned into fat and it can accumulate. And then there was observational data from large cohorts of people where they basically showed that fructose intake was associated with levels of non-alcoholic fatty liver disease. So that was the first kind of, hey, we should look into this. Now, the important thing to know about observational epidemiological data is it's hypothesis generating, right? Even when you statistically control for things like height, weight, sex, all these other things, is typically when we look at large nutritional databases, people who have the highest fructose consumption are not the people who are eating lots of fruits and vegetables, right? So, I haven't done this analysis and I don't know what the actual data is, but I would assume if you took, food frequency questionnaires and you took people's fructose intake, they would probably be inversely correlated, because most of the time people who get high fructose loads, they have a cluster of other unhealthy behaviors. They're typically more overweight. They are, typically more likely to smoke, drink. Their fructose sources are usually from sugar sweetened beverages, all sorts of things. So it's really hard then to say that fructose is really a large contributor to the risk of non-alcoholic fatty liver disease. It's associated, but how much of that risk is it really comprising, right? So that's one of the really hard things to do with epidemiological data, trying to define, how much of this correlation explains the risk. So whenever you have positive signals like this in big observational data sets, epidemiological data sets, you have to then go conduct intervention studies, right? You can either use animal models or you can go to humans. And you can actually take people and you can go, okay, I'm going to take people and I'm going to overfeed them large amounts of fructose and see what happens to their liver. Now, there's been a lot of studies done on this, right? We have really kind of hammered this point to death. There's been a few studies published. So one of them was a short-term study where they basically gave them, 3 or 4 grams of fructose per kilogram of body weight for a week and looked at what happened. So they basically gave them, let's just say, about 255 grams, and they actually gave them either glucose or fructose. And then they even had a higher intake where they gave them 340 grams of fructose a day for 7 days. And they looked at what happened. And basically here was the summary of that study. So if you took people and you gave them 255 grams of straight glucose, 255 grams of straight fructose, or 340 grams of straight fructose, and you don't exercise, you see a decrease in insulin sensitivity, and you see an increase in liver fat accumulation. But they also had an arm in this study where they gave them 127 grams of fructose a day. But those people didn't have anything. So it appears that to have these, we'll say negative adaptations to fructose intake, it has to be incredibly high, and it also appears when you consume that much in just straight glucose. So it doesn't really appear to be a fructose problem per se, but probably a nutrient overload scenario, right?
Mm-hmm.
So keep those numbers in mind of, let's say 250 to 350 grams, you start to see fat accumulation in liver and you start to see changes in insulin sensitivity. But at about 130, you don't really see those in a short-term study. Now, there was another study that showed very similar findings. So this has been repeated over and over and over and over again. And there's some additional nuances, and people who are insulin sensitive and insulin resistant appear to metabolize fructose a little bit differently, but largely how that applies to people in terms of real world scenarios, it turns out it doesn't really matter a whole lot. So the next real question you need to ask is, okay, we know that there can be some bad things that happen at super high intakes, right? So think about, if you do the math and you take 250 grams of fructose, which was kind of where they started to see some of the bad things happen, that's about 12 to 15 apples a day, right? How many people are eating that many apples a day? Not that many, right? So people who are consuming that amount are probably having, how many grams of fructose itself are in a can of Coke? But that would probably be close to, 15 to 20 cans of Coke a day too. So those are really high intakes. So now if we actually look at what the normal intakes of fructose are, we can actually look at the NHANES data in America, right? It's not perfect and it's not exactly accurate, but it gets us close enough to where we can make an assumption. So before I kind of walk you guys through the numbers, think about what this survey data represents. It represents a United States population which, at the time was probably 25% obese, about 60% overweight. So these are people who already have, we can say, not healthy lifestyle and not healthy nutrition habits. Amongst people who were 12 to 18 years of age, their total fructose consumption is about 73 grams per day, right? And that's the highest group. That's teenagers, because teenagers, we all know how teenagers eat, right? They just eat whatever, it doesn't really matter. And so at the highest intake, the average intake is still about half of the low end of that one study that didn't show anything. And it's about, a third to a quarter of what the actual studies that show negative impacts. And if you take adults, so people who are, over 18, the estimated fructose consumption is about 55 grams a day. So it's not that these people, even on average, are consuming huge amounts of fructose. So to then make the leap that fructose consumption amongst our population is driving the non-alcoholic fatty liver disease is, I don't think, a solid hypothesis. I think the real truth is all the metabolic adaptations that come with being overweight and insulin resistant are what's driving the ectopic fat accumulation in the liver. I don't think fructose consumption is causing it. I think it's all these other downstream effects are actually causing what's happening in the liver. And I think that's the more accurate way to interpret a lot of this data.
Yeah, I did some math in my head. 250 grams of fructose would be something like 500 grams of carbs.
Yeah.
In a 1-to-1 ratio, which at around a 10% carb intake in a can of Coke would be 5 liters of Coke.
And I don't think there's that many people drinking that much Coke a day.
Yeah, that's just insane. I think there's a lot of confounding variables there that you've mentioned, because we are talking about a population that is already overweight, already obese, and already has insulin resistance. So if you dump that shit ton of fructose you mentioned upon them, then yeah, it's probably likely that we are going to see some sort of negative health consequences. Do we have any data that's tried to delineate between these two? So fructose intake per se versus the overall health status of the people involved in it. So do we have any data on healthy people who maybe even exercise, so their liver glycogen would be depleted a bit?
I don't know what that data looks like off the top of my head. I haven't gone into a lot of the big data sets and tried to tease out some of those subset groups, so I don't know for sure. But one of the things we do know is largely healthy behaviors cluster, right? If you take a population data set of 2 million people and you were to pull one person who they've got a BMI of 35 and they don't exercise, they're highly likely to be somebody who consumes high amounts of processed foods, including processed meats and processed carbohydrates and processed fats. They're more likely to smoke. They're more likely to engage in a whole lot of unhealthy behaviors. And then if you take another random person out of that and they've got, a BMI of 22, they exercise 5 times a week, they're also more likely to eat more fruits and vegetables. They're less likely to smoke. They're less likely to be heavy drinkers. So I think it's probably a fair assumption to say that fructose intake amongst those two different people, not only are they quantitatively different, but how it gets consumed in their diet is probably also substantially different.
Yeah, for sure. So should people worry about fruit at all? Or is that something that is just best to forget about and just have your fruit?
I think it's safe to say that fruit consumption is not what's driving a lot of the large population health issues we're having. I think people who are attempting to lose weight, fruit is a fairly critical part of your diet. I will make the caveat, though, that large consumptions of dried fruit really drives up calorie intake pretty quickly, right? If you go to Costco and you buy one of those bags of dried mangoes, you can polish that bag off in about 4 hours, and that's several thousand calories. So I would say fruit in its whole natural form is probably one of the bigger pieces to keep in your diet, especially if you are somebody who's, trying to lose weight or something like that. But I don't think the fructose load from, even something like 2 or 3 apples in a day is causing you a lot of metabolic issues.
Yeah, it just blows my mind when I see these stupid articles listing popular snack options, and I see something like a dried fruit in there. Because I have friends who are bodybuilding competitors and they carb load on dry fruits, like you said. So it's so super easy to down like 100, 200 grams of carbs in like a couple of minutes if you wanted to.
Yeah, it's one of those foods that is harder to control consumption because it's a very energy dense food source, and it's usually very palatable. It's very sweet. It's usually got good texture, and it's easily available, and it doesn't seem like you're eating a lot of food. So I think for a lot of people, it becomes a food that gets overconsumed.
You've mentioned at the beginning that the fructose is sweeter than glucose, and for that reason, fructose, I don't know how popular that is, but for a while at least, it has been advertised as a suitable replacement for diabetics in order to better control their blood sugar, because fructose doesn't have much, if any, effect on insulin secretion. And one of the other concerns that my professor expressed when we discussed fructose, actually that's how it came up. She asked me about my opinion on it, and she said that, because fructose doesn't release insulin, you kind of get that sweet taste in your mouth, but you don't get the insulin from it, and you just keep craving it, and basically you don't get a lot of satiety from it, and you kind of left wanting more, and you just end up consuming even more of this fructose containing food. What do you think about this?
So there's a lot of questions buried in that, but I think probably one of the big pieces is this idea that circulating insulin levels play a large role in satiety. And I think that's been largely disproven, to the point where we know that insulin itself doesn't play a major role in determining satiety and hunger, right? I can't remember the author of the study, but there was a study where they actually just infused insulin into people while maintaining blood glucose levels, and they were able to show that doing that doesn't really change your hunger, right? I can't remember if it was perceived hunger or if it was other hormonal signals of hunger, but it appears that in most people, circulating insulin levels don't really appear to be a large driver of hunger and satiety signaling, right? A lot of other things play a role in satiety. It's, a lot of times it's food volume, it's other hormones like, how your body responds to foods and releases of things like GLP-1 and stuff like that. But I think the idea that fruit makes it hard to control hunger due to lack of insulin secretion is not supported by any of the scientific literature that I've come across. So I would have to say that that's largely a false narrative.
And what about fructose's use as a sweetener for diabetics, for example, or just for someone who is trying to make a health-conscious decision? Because you know how it is. People are well-intentioned, and the bulletproof coffee is a perfect example of this. People are trying to make a positive impact on their lives and health, and then they replace their coffee with a 600-calorie drink to lose fat.
Yeah, so the idea of using fructose as the carbohydrate of choice because it doesn't release insulin to a large extent was investigated quite thoroughly. I believe it was like the late 90s to early mid 2000s, and it's been a while since I've actually dove into that literature, but the large majority of those studies were fairly negative in terms of, does substituting most of your carbohydrates for fructose in people with diabetes help you regulate blood sugar a lot better than glucose sources because of insulin? The short answer is not really, right? Regardless of whether it was type 1 or type 2, is fructose doesn't really appear to be a far superior carbohydrate source than glucose, but it also doesn't appear to be inferior, right? So how you manage your blood sugar by all the other lifestyle pieces, it appears that how you substitute fructose and glucose isn't a gigantic contributor to glucose management amongst those people. Now, there could be updated literature in the last few years that contradicts that statement, but I haven't seen any.
I haven't seen either, and simply from a energetic point of view, it wouldn't make, like, I could see the value in that kind of thinking, but simply from a glycemic load perspective, it wouldn't change a whole lot. So
yeah, and I think one of the big things to think about is what is the context of that fructose, right? If I have a diabetic client, somebody who's type 2, they're trying to lose 60 pounds, even if there was overwhelming data to suggest that lower fructose or higher fructose was substantially better than glucose, I probably still wouldn't tell a client, don't eat this apple, or, don't eat some other fairly nutrient dense, low energy density glucose source just because of the acute changes in blood sugar and how it's managed, right? You have to think about it in the overall context. People who, I know like Spencer Nadolsky spends a lot of time as a clinician working with people who are overweight and type 2 diabetics in their behavioral and their dietary status of how they get to where they want to be. And so much of these ideas of fructose versus glucose really come in the context of your overall diet and how it impacts your metabolism down the road, right? I think a lot of these studies focus on a singular outcome of, A1C or glucose variability or, postprandial glucose excursions or postprandial insulin excursions. And you have to think about it in the context of how people eat, how weight loss impacts all those measures over time, and what's the long-term goal of how you get to places. So that's the other way to think about a lot of these pieces and how you determine, carbohydrate sources in your diet.
Yeah, I think it's just like you said, people kind of lose the forest for the trees, and usually what happens is that they take some sort of a biochemical reaction, like you said, or some sort of a in vitro data, and then some sort of a news headline picks it up and is distributed, and the headline usually says, well, the fructose is healthier than glucose because of this, and then some sort of processed food comes up which instead of glucose it has fructose, and people then think, well, this is healthier, I can eat 3 pieces of this instead of 2 of the ones that were sweetened with glucose. And at least when we talk about artificial sweeteners, they don't have any sort of a calorie content. So if you replace your soda with your diet drinks, at least you create a net deficit of 400, maybe 600-800 calories potentially. But then again, people then kind of again lose the forest, and they say, well, the same stuff that I said about fructose, that, well, artificial sweeteners don't really release insulin, or they do, and you kind of left with this sweet taste in your mouth, but you don't get the calories, and then your brain, it's kind of tricked, and then it craves sugar again, and you end up eating even more. And just like you said, it completely ignores the context of the person and the overall lifestyle of the person itself.
Yeah, and I think that's one of the really strong arguments. I mean, I think artificial sweeteners are a great example of why you need to look at research on the topic at various different levels, right? So you need to look at the basic science studies, right? How do artificial sweeteners impact things like insulin sensitivity, hunger signaling, microbiome, et cetera, et cetera? What are the doses at which those effects actually happen in rodents and then in humans? Also, the other thing you then need to go to are outcome-based studies, right? So if you have people and you know that swapping soda for diet soda is A, higher adherence, and B, leads to weight loss, and then you know that weight loss impacts insulin sensitivity, microbiome, et cetera, you really need to figure out which level of analysis do you care about and which one gets you the results you want. Right? So is it, okay, this study shows that X amount might change the microbiome, that might have negative health effects, or do you go to a human study and you say, look, I have a client who's been consuming 4 or 5 Cokes a day. We need to get 50 or 60 pounds off them. That then will improve all of their metabolic parameters. It'll probably improve their microbiome. It'll improve their ability to move and be active. And we can use, 3 or 4 Diet Cokes a day for 2 years to get them to where they need to be. And then we can have the conversation of, okay, there might be some potential effects. Now we need to address this issue, right? So you have to have the appropriate level of where is the information getting me to where I need to go.
Yeah, it pisses me off when we have, like you said, we are interested in an endpoint and we have solid data investigating that exact endpoint, and then people kind of reference 5 steps back the first or the second study that started this whole process, and they justified their argument with that when we are talking about the endpoint, which was kind of like step 6.
Yeah.
Okay, so you've mentioned some numbers there. If you want to leave the people with some sort of a practical takeaway or some sort of a number to shoot at, what would be an admissible daily intake or a recommended daily intake of fructose people should aim or should try to not go over?
Yeah, so there's kind of two levels to this answer. There's the what the literature has shown us example, and then kind of what's the pragmatic answer is in one of the biggest meta-analysis, basically trying to pull all these studies done on humans where they've fed them various doses of fructose and looked at, how does it change your blood lipids? How does it change your liver? How does it change insulin sensitivity? All these things. And it appears that about 100 grams a day, anything less than that, fructose intake doesn't appear to alter any metabolic parameters in a meaningful way. So from the research perspective, less than 100 grams a day appears to be, we'll just use the word okay, right? There's really no big negative health effects. From a pragmatic perspective, I like to give people guidelines that are lower than that, because if you are consuming 100 grams of fructose a day, that's actually a fairly high fructose load, right? The average NHANES data was about 57 grams a day, I think it was. Or 55 grams a day. So if you're consuming 100, that means you're probably pushing, a lot of sugar-sweetened beverages, a lot of foods with added fructose as sweeteners and stuff like that. So I like to tell people, try to be below or around that average a day. So under 50, under 60 is probably a decent goal to shoot at, right? That's 2 to 4 pieces of fruit a day, or, a couple pieces of fruit with one beverage or one thing that's sugar sweetened or things like that. And then you're still within, you're about half of where the cutoff is where things start to get bad. So those are kind of research numbers, and then thinking about food and context numbers.
Mm-hmm. Yeah, 100 grams of fructose would be, again, something like 10 apples. If you only hit that from fruit itself, that would be a pretty notable feat to achieve daily.
The durian writer 30 bananas a day guy from 2010 or something.
Yeah, something like that. From bananas, yeah, you could get it, but from apples, I think I had days when I had 10 apples, but I usually have around 4, but 10 each day, every day for the rest of your life, that would be, if they say that an apple a day keeps the doctor away, then 10 a day should make you immortal or something.
Yeah, and also usually if you're eating that many apples a day, you're usually probably having a little bit of a gut problem trying to handle all that too. A lot of people would have a lot of GI distress.
Or those FODMAPs.
Yep.
Okay, just one question popped into my mind. If you have someone that maybe wants to gain muscle and they're trying to go in on a super high carb diet, because that's something that I've been looking at recently. We know that, for example, overfeeding on saturated fat can cause more fat gain than having a lower saturated fat intake. Do you think that could be the case with fructose? So, for example, if someone wants to have a high carb diet that is really high in fructose, maybe they consume a lot of dry fruit or something like that, that could negatively impact their insulin sensitivity, for example, or something like that, or that's just kind of highly speculative?
I would say I'm always somebody who errs on the side of caution and tries to take the available data and make the best informed decision we can. So if I'm thinking about, I have an athlete who's, consuming 600 or 700 grams of carbohydrates a day, and we know that, pushing 200, 250 grams of fructose a day is starting to get into some of the areas where metabolic parameters shift negatively. You're probably at that point wasting a lot of fructose because it's being converted to lactate, which can be used for fuel, but is not the best for trying to gain muscle mass. You're probably more than repleting your liver glycogen. So I would say if you're putting somebody on a very high carbohydrate diet to gain lean mass, is think about what you're trying to do, right? You're trying to optimize as much as you can to grow muscle tissue. So I would say put the vast majority of your carbohydrates to glucose, maybe put 10-15% of that towards, fructose, so you can just kind of maximize liver glycogen replenishment and maximize how much glucose is going to the muscle tissue. But I wouldn't get crazy and have people consuming 30, 40, 50% of high carbohydrate diets on fructose.
Yeah, in general, it's better to err on the safe side. Michael Hall, who runs the Nutrition As I Know It website and blog, he had a question. He said that he suspects that you apply fructose to your hair to keep it looking luscious.
Hey,
please confirm.
Tell him that it's not helping me prevent the gray from coming in. So it may keep it luscious, but it doesn't keep it from turning gray.
Yeah, you're not cleaning your senescent cells. I hope I said that right.
Nope. Maybe that's my problem. Maybe the banana a day is turning my hair gray. Maybe that's the answer.
Yeah, you need more fasting and more time restricted feeding.
That's the next rabbit hole, right?
Yeah, let's not go there. Okay, just before I let you go, could you let listeners know where they can find you if they want to check out the blog you run, which is excellent, and your social media accounts?
Yeah, so a lot of my writing lives at science-driven-nutrition.com. I release articles every couple months because I like to make sure they're very thorough and not headline sensational pieces. All of my coaching is done through eattoperform.com. So we run a big online nutrition coaching platform. We've got one of the only mobile coaching apps for nutrition. That's pretty cool, and we're relaunching some additional software that'll be pretty cool. So if you guys want to check that out, feel free to. And then find me on Facebook or Twitter or wherever. I'm pretty easily accessible, and just be happy to talk to anybody who's interested.
Great. I will link all those in the description of this episode. So with that, I would like to ask you the final question that I ask every guest who comes on, and that is, what is your definition of success?
Oh, my definition of success it's changed over the years. And probably the one that I currently like the most is, I just read the book Principles by Ray Dalio, and he had a really great quote in there. I think it goes, I realized the satisfaction of success doesn't come from achieving your goals, but from struggling well. And I think that would probably be, for me currently where I'm at in my life, the best way to define success. I think so many of us end up focusing on, an end result, and the more things I accomplish in my life, the more I realize that it's the journey that really is what I enjoy the most. And so really being able to enjoy the journey and the hard work is probably the best way I've learned to define success. So it might change tomorrow, but that's what it is today.
Yeah, that's so important. And I think that's exactly where the 7th place trophies are hurting people. They kind of downgrade the entire value of the struggle, like you said, of the journey itself. And I think we'll just end it there. I would like to thank you for coming on and giving up your time to share your knowledge with us. And I highly appreciate it, and all the work you do at Science Driven Nutrition.
Yeah, perfect. Thank you. I really appreciate the opportunity and the chat. I think it was a super helpful discussion, and happy to come back anytime.
Awesome. Take care.
All right, take care.